Hey guys, let's balance some chemical equations today. And we're going to start with this problem right here. Now, at first glance, you can tell that there are two separate elements in here. We've got nitrogen over here, we got hydrogen over here, and on the other side we just have nitrogen and hydrogen, just like, sorry, that's the wrong color. We just have nitrogen and hydrogen. Wait, that was what am I doing? Okay. So, how do we balance this? Well, we can see that we have two nitrogens on the left and we have one nitrogen on the right. What could we multiply them by to make them the same? So, we can multiply the right by 2. So we can get two of these molecules, and that'll make it so that there are two nitrogens on the right, which successfully matches the 2n on the left. Now, is the equation balanced? We don't know yet. We have to check the hydrogens. So let's see. With the 2, we now have six hydrogens on the right, and we have two hydrogens on the left. Well, we can just multiply the left by 3, and then we'll get 6 hydrogens. And we could do this because the hydrogen is all by itself here. That's the thing that's good about these singular elements, is that you can multiply them together to get freely. It's not like, let's say we had a hydrogen 2, like on the left, but we also had like potassium and chlorine tied to it. Now, if we multiplied hydrogen 2 by 3, we would also multiply this entire thing by 3. So, like, that's the thing. Now, let's see. These are matching. These are matching. So the equation is balanced. We have the answer will be just 2N2 plus 3H2 to 2NH3. Let's do the next one. This is the next problem. So it's a bit more stuff going on, but we can see that we have an oxygen by itself all alone over there. So if we have something alone, our general rule of thumb is to leave it till the very end. We want to deal with the big things first. We have oxygen, and then we have KCl, potassium and chlorine. And potassium and chlorine, this is also by itself, so this is really good. We just need to increase these to a value where we can satisfy both. And the thing is, the only complicated thing about in this problem is that we have a 3 in the O. We have O3, and we need that to be equal to O2. So we can have, if we have one of these molecules, we'll only have 3 oxygens, and on the right, we'll only have 2 oxygens. But if we multiply the left by 2, and we multiply the right by 3, we can get the left and right to both have 6 oxygens. Now, let's see if they're balanced. Wait, hold on. You could see that on the left, we have 2 KCl's. On the right, we have 1 KCl. So we also need to increase the KCl by 1. We need to have 2 of them so that these are both matching. Hopefully you could see that we have to like experiment with one thing and then try to get the other thing to also match. So our finished equation will be 2KCO3. KCO plus 3O2. Alright, we're going to do a multiple choice question now. Balance the equation using the smallest whole number coefficients. So for these multiple choice type problems, you just want to do process of elimination like every other academic subject. So here you could already see that we don't really need to mess with this. This is going to be the same all the way through. And then we have this. This is the most decisive row. Let me do it in different color. This is the most decisive because for these rows, we only have one value that's different. And here in this row, we only have this value that's different. So let's do the red first, which is all sodiums. So on the right, here on the first one, we have 2 sodiums. 2 sodiums does not equal 3 sodiums, so that's not equal. On number 2, we have 2 sodiums, and we also have 2 sodiums, so that could be equal. Number 3, 4 does not equal 1, so number 3 is gone. I'll just do this. And for number 4, we have 2 sodiums and 2 sodiums. So for now, we are between number 2 and number 4. So now let's go over to this side, this bit, to analyze. And we have two H2s on number 2 and 1 H2 on the second one. On the fourth one, I mean. So let's see. We got on the left here, we have 4 H2s in total, as you can see. And on the right, we also have 4 H2s. 2 times 2 is 4. So that is correct. This is the one we want to choose. But let's just check for a moment that number 4 is definitely incorrect before we go any further. We have 4 hydrogens on the left, and we have 2 hydrogens on the right. That is incorrect, so the right answer will be number 2. Let's do another one. Balance the equation using the smallest whole number coefficients. Okay, this one has a bit more going on, so let's just see. On the right here, if you have a parentheses with the value outside it, that just means that's just the equivalent of, let me just write it out for you guys. And oxygen 3. This is the exact same as N2O6. These are the exact same. You would do it in math, like with the distributive property. That's how you counter these. And for this one, we have 6 oxygens on the right. And we also have 2 nitrogens. 6 oxygens and 2 nitrogens. And over here, this is where the oxygens and nitrogens live here. Now, we need another one of these. So automatically, we have to increment this by 1. Let's make it 2. And now, we have the nitrogens and oxygens equivalent because we have 2 of them on each side. Hopefully you can see that. Next, let's see if the AGs are equal. We have 2 AGs on the left. We have 1 AG on the right. That's not good enough. So we should also increment this by 2. Now let's check if the chlorines are equal on both sides. We have 2 chlorines on the left. On the left. And we have 2 chlorines on the right. That's good. Now for our last one, I hope this works. We're going to check the last element we have, magnesium. And we have 1 magnesium on each side. So the complete balanced equation is just 2 Ag NO3 plus MgCl2 to 2 AgCl plus Mg, no, 3, 2. Like that. That's the complete balanced equation. Let's do another one. This will probably be the last one. And this is another multiple choice problem, but this time we have some nice large numbers. Please don't be afraid of these large numbers. These usually just mean that if you got large numbers on one side and the numbers here are quite small, these are all 1, is that you'll probably have bigger numbers in your balanced equation. So let's check first. We have 10 carbons on the left, and we have 1 carbon on the right. This is not a carbon. That's a chlorine. Those are different. So let's just first start by putting 10. That's ugly. Putting 10 carbons on the right. Now they're equivalent. Let's check the hydrogens. We have 16 hydrogens on the left, and we have 1 hydrogen on the right. Let's just multiply that by 16. So we have 16 hydrogens now, that matches, but we have 16 chlorine too on the left. On the right. 16 chlorines here. But on the left, we only have 2 chlorines. Well, let's just multiply 8 on the left. That makes 16 chlorines, so our final answer will be just 1 of these. 1 of these C10H16s plus 8 chlorine 2s, arrow, 10 carbons plus 16 hydrogen chlorines. So that's our final answer, and let's just check which one it is. So we want this one. It's this one right here. That's the one that matches, so this is the answer. Thanks guys for watching this video.